Hi, welcome to this lecture. Here I will introduce you to another tool for creating RDMs, and this is Workbench. And Workbench is something that comes along with MySQL, so it is called MySQL Workbench. And I posted the information like how you can download and install a MySQL Workbench on your machine. So I shared a YouTube link which I found very interesting and has very simple, straightforward directions for installing MySQL Workbench. Alright, so what I plan to do in this lecture, I will give you a recap of data modeling. We did discuss about data modeling, but initial few slides I will devote again on data modeling, like why is that important. Okay, so we have learned these things. We learned about the way how we can model a single entity, and we also looked at modeling more than one table or multi-table database or multiple entities, using the example where you have one table that represents the data about the nations, and there's another table which is representing the data about shares. So either you can look at that from tables point of view, or you can look at that from entity point of view. So you have two entities, one entity corresponding to the nations, and there's another entity that corresponds to shares. And then we modeled one-to-many relationship, but we did that using MS Access. So personally, I like this tool better. Workbench I prefer over MS Access, because the RDM looks you know, a lot better. Okay, so let's try to revise what all we have learned, and then we will try to do the same on Workbench. Okay, so what is data model, right? Let's start from there. And we know that when we are designing a database, then we should start with the data model, because with the data model we'll get some idea about how to structure or implement our database. So the question comes, like when you're saying that you have some data model, it could be hierarchical, network, or relational. Well, we are mostly concerned about relational data model. Now the question is, what should be there in a data model? What defines a data model? So we saw this definition that in a data model we should have some concepts, or you can say this is an integration of concepts, or is a collection of concepts which we need in order to describe the data, and in order to describe the relationships that might exist between the data in our database. And it should also have some concepts for specifying constraints on the data, right? So we have learned a few constraints. If you remember, we went over these things. So since we have done it, so what I'll do, I will write a note here that will have, I'm looking for my pen. All right, so when this question of constraint arises and we are looking at relational databases, we learned, right, what could be different constraints. So we have learned about domain. So domain is also a constraint. So once you specify an attribute and you have some understanding of the domain, then domain will impose a restriction on the values that an attribute can take. Okay, so domain constraint is one. Then you have primary key constraint as another one. So if you're calling anything as a primary key, then that specific attribute should have unique values, and you cannot have duplicates for primary key column. We also learned about foreign key. Alright, so all these things that I'm putting right here are example of constraints. So in your data, you will have to have some domain for every attribute, because in every attribute you are using every attribute of an entity to describe that entity. Right, and for attribute anyway you will have values, and domain will decide what value an attribute can take. Similarly, if you have a table or an entity, then you should have a primary key for that table. Okay, so these are all constraints. A foreign key, when you're thinking of relationships between two tables, then for at least one example that we have seen, which is one to many, you need the concept of a foreign key at the many sign of the relationship. Alright, so these are all constraints, and since we are since we are handling relational databases, so we have our different approach of doing it. But the data model, which is relational, has all the support. Great. So now if you want to look at the structure, what structure we should have in a data model, then usually we have these three parts: a structural part, a manipulative part, and integrity rules part, right? So structure means how do you represent the data. Here we represent data in the form of a table, right? So we will define like how many tables we'll have, what would be the the kind of relationships that we'll have between different tables, and all that forms the structural part. Manipulative part, I believe, is something like that relates to how will you access the data. So in relational databases, I'll say SQL should be considered as the manipulative part. So that's how you will query the database, right? So that's the manipulative part. And integrity rules are something like this, right, which I already mentioned. So you can define your um, constraints. So how do you define the constraints and all that? So all these concepts taken together would define a data model. So relational data model, right, the one that we are interested in starting in this course. So how do you model a reality? So we need some database. We need database so that we could efficiently handle the data related with some enterprise or some real life entity. So say we have a university, and the university is pretty new, and the students, they start registering in, but we want to keep that information in a database. So the whatever database you create, it should model the reality. That's the biggest challenge. Okay, so anything that we might face in the real world should be captured in the database also. So the message is that the database that you design, it must mirror the reality, the real world, and which is little difficult to do. So it, the message is that since it's a very challenging task, which is of designing a database that should model the reality, so we should go in a systematic manner. So that means before implementation we should have a design phase, and in the design phase we will not think too much about implementation. We will try to design at a conceptual level the database system which will reflect the reality. We don't want to miss any information which is there in the specifications that we have got from the client. We want to make sure that we have included all the specifications that the client wants in our design. And then once the design is finalized, once we know that we have taken care of all the components of the enterprise for which we are designing the database, then we will go to the implementation. So modeling or designing is important. That should be the first stage in designing the database. So there are a number of approaches. So we are all revising these things we have already gone through. So you have object modeling, which is used for mostly object oriented software design. So that is also very common, very popular these days in database design. We have diagrams. Diagrams have been there for a while, and classically they are considered as one of the very strong tools for designing databases. But recently they have been confined to just the textbooks because people are preferring other models, right, like UML and all, compared to diagrams, but they're still popular. So if you're taking a course in databases, you're supposed to know what is an diagram. We will learn about diagrams in the lectures to come. Right here, we are more focused on RDM, which stands for Relational Data Modeling diagrams. So these are slightly interesting for the reason that when you create relational data modeling diagram or the RDM diagram, then these diagrams are somehow related with the relational model. Like when you create it, then you can clearly see the table and you can see the connection between the tables, and you even see the columns in the table. So it's directly modeling the relational model. That's the point. RDM is a design approach which directly models the relational model. I'll say that this RDM is for relational data modeling, whereas the ER models that you have are very generic. So when you create an ER diagram, that it doesn't mean that the ER diagram should be implemented using only the relational database. That's not the case. ER diagram is more generic, okay, which can be implemented by any implementation, relational or non-relational. Whereas RDMs are specific to relational databases. So that's the difference which we should keep in mind. Alright, so let's move on. Okay, so how do we represent an entity in the RDM? That is represented using a rectangle. You can see right here, shares is an entity that we have been using in our examples. So you'll use represent that as a rectangle. Now, well, every entity that we have should have some property associated with that entity. So as an example, we are looking at share entity right now. So how do we define shares, right? So for any instance of share, you should have the corresponding code value for the share. You should have the name for the share, price, quantity, dividend, and PE. So all these things that you're looking at are the properties of the share, and these properties in database systems are called attributes. So attributes are needed to define an entity. Okay, and in the RDM, this is how you will show your entity. You will show your entity with the help of, you'll show an entity as a rectangle, and in the top of the rectangle you will give the name of the entity. Here we are calling it that shares, and then you have different columns, which means different attributes of this entity: code, name, price, quantity, dividend, and PE. And a very interesting point which I already mentioned in the previous lectures is that when you define an entity, then make sure that the attributes of the entity have a meaningful name. So for shares, the different attributes that I have named those in such a way that you could understand what we have in that column. I did not name it as X, Y, Z, A, B, C. That's something we kind of do in programming when we are learning programming. Any person who is an expert programmer would never write X, Y, Z, A, B, C for these attributes in the program as well. But when we learn programming, we have this tendency of using X, Y, Z. So these variables are not very meaningful from the name. But in databases, attributes should be meaningful. This is very important. Okay, so attributes have been named appropriately. Let's move on now. So now we have this concept of the primary key. I believe you understand what primary key is. Anyway, if not, then let's spend some time on primary key also. So whenever you have an entity like shares here, then we should have at least, well, it depends, right? You can have a single attribute with that property, or sometimes we need more than one attribute uh, in an entity to define its primary key. So the message is that primary key could be atomic or non-atomic. Atomic means when you have a single attribute which has the capability of identifying each record uniquely, then we call that as an atomic primary key. sometimes we need more than one attribute uh, to uniquely identify the tuples in a table or an entity. So in that case, when you need more than one attribute to define a primary key, then we call the primary key as composite. Okay, so anyway, whether the primary key is atomic or is composite, the role of the primary key is to uniquely identify the records in the table. Okay, and how do we show a primary key an ER diagram or an RDM? So in RDM, we put a star before the name of the attribute. So in this shares, in the top shares entity, we have code as the primary key. But if you create the same table using MS Access, then you realize that MS Access usually asks us if it should add a primary key for us. So if we ask the MS Access to provide a primary key for us, then it will add one field which is ID right here. Okay, so in place of using code as a primary key, we will use ID as a primary key. All right, so the message right here is that how do we designate a primary key in the RDM? So we are using star just before the attribute which we will be using as a primary key in our table or an entity. Good. So we looked at all these aspects, right? So I'm going through that again, and I'll be little fast because we know all these things. But anyway, now the point is, which modeling approach should we use? Should we use traditional database approach like ER diagram based approach, or should we consider object oriented modeling? Well, I'll say for this course we should not get into object oriented modeling. We will confine to the relational modeling, more so on RDM, because our project will not be so complicated. So for a very complex project, probably if you're working in a big organization where they are developing a really complex database system, which involves programming in object-oriented language like Java, then you might think about object-oriented modeling. But in our case, we will keep it very simple, and we will stick to the RDM approach. Okay. So now what I will be telling you is the tool MySQL Workbench, and as I mentioned, I have already shared a link on the YouTube that you need to follow to install MySQL Workbench. If you are struggling, please let me know. Join me in my office hours, and I'll try my best to help you out with the installation. Okay, but if you have window machine, then I believe that the tutorial that I have, the link to the YouTube on Blackboard, is good enough. Alright, so I will go over these slides later, but first let me give you the demo. So here I have installed MySQL Workbench. It looks like this. That's the icon. So let me open that up. I say MySQL Workbench, and here it is. Alright, so here you will enter through root. I will click that. The most important thing about MySQL Workbench is the password. So when you are installing, then the fellow who's there in the demo that I have shared on Blackboard makes it clear that you need to have a password, and you should not forget the password. So make sure that you have a simple password that you remember, otherwise you'll have difficulty in getting back to the system, because recovering password is not straightforward. Okay, so I will put my password, and only through password it will allow me to enter. Alright, so I succeeded. So what we will have to do, here you can write queries, right? So I am trying one query that says show databases. I will run this thing. It is showing some databases, but let's not do queries right now. I'll do query part later. First we need to learn about modeling, because very soon I think you will have to start working on your project, And for project, the first stage is to submit the RDM of your database that you're designing. And I prefer MySQL Workbench over MS Access because the diagrams that you create using SQL Workbench look a lot better compared to the MS Access thing. So how do we create the RDM? That's the topic for the discussion today, using Workbench. So I hope if you have installed Workbench properly and if you remember your password, there should not be any issue in coming to this page. Then you go to File, and in the file you should click a new model. And when you get new model, like here you can see you have a lot of options available to create your new model. What we have to learn today is about the diagram, so don't worry about the later part. Just click add diagram. When you do a double click, then it will show you this canvas kind of thing where you can create your RDM. So it's pretty straightforward, right? So if you practice, you will realize that this is a lot simpler compared to MS Access, and the diagram that you'll be creating also look a lot better compared to MS Access. That's my personal opinion. So here you have bunch of options which will help you in selecting the component of the RDM. So we will select a table, right? So you will click this. Okay, and after clicking, when you click on the canvas, you have a table. Double click this guy. So when you double click, then you get this section. So right here you can edit the table. So what I will do, let me create the table for nations. Alright, we are doing the same stuff, the same problem we are solving using MySQL Workbench. We are not solving a problem, rather we are creating the RDM. So that's the reason I corrected myself. We are creating the same RDM on Workbench. So the name of the first table that I'm creating is nations. So I will print enter, and you can see the change. The table name got changed to nations. Now I should think about creating my columns in there. So let's start. I'll say ID, right? Why ID? ID is my primary key, right? So here you have bunch of options. When you created the column with the name ID, it will say what data type do you want to have for ID. So you have all these options, right? Different data types that can be associated with ID. I'll keep that as an int, and then it picked the options by itself. Made that as primary key. PK is for primary key, and N is for not null, UK is for unique, and so on and so forth. So what's being the primary key, I'll keep that as I will pick these two options, PK primary key and NN for not null. Let's press enter. By entering, it is asking me for the second column. What should be your second column? I'll say code. I should double click this guy. I will say code, and code was varchar. So varchar is a data type with SQL that is for string. So varchar means variable character size 45. So it's a string with the maximum length of 45. I'm saying fine, I'm fine with that. If I want, I can make that not null. Alright, so I added that constraint that code should be not null. That is up to us, and I'm saying that if you have a country or a nation, then we must have its code. So for that reason, I made that not null. So if somebody is entering a value with the country code as null, then it should result in some error. Good. So we are done with this. Let me click to get another column. I'll call that name. I'm fine with varchar 45. So okay, exchange rate, you remember that was another column, exchange rate. Now pay attention to exchange rate. If you could recollect the values that we had in the nations table, then the exchange rate was a decimal value where we have decimal and some digits even after decimal. So probably variable character, that is var data type is for string. I should not uh, define exchange rate as varchar. Should instead define that as double. Alright, so I change that right here. And I believe I'm okay, right? I don't remember how many attributes we had, but I think we are good. ID, then code, nation name, and exchange rate. We are good. So I will close this table. Okay, so in the RDM that you were doing or designing, or I am designing, I have these 4 attributes. I'm done with one table. Let me think about the other guy now. So the other guy was, or the other table was shares. So I will click this table icon here and here. Same step, double click this table. And let's edit this one. I'll say shares, that's the name of my table. And then I should come for columns. ID, the same way, right? And by default, it is by primary key as well as, and when it is primary key, it's not null as well. So let's go on and pick the second attribute. I think the second attribute was code. I'll keep that as varchar and I'll make that not null for the same reason. I don't want shares code to be null. That's how I want it, right? So it might change in your case. Alright, so share name is my third attribute. It's variable character. I'm fine with that. Then you should have share name, and what else we had? Price. Okay, before price, let's put the quantity. Now the quantity should not be variable character, right? Varchar, because it's a whole number, right? So ideally we should keep that as an integer. Quantity will be a whole number. Integer is the best data type for quantity. Well, price. After that we had price. Price is something which ideally we should make as double. I hope you follow me. You're following me that why should we have price as double. Then we had dividend. Dividend. This should be also double for the same reason. I am expecting a double value. After dividend, what do we have? PE. Right? PE should also be a double. Where did that go? Right here. And then we had another attribute, if you remember, the foreign key attribute, which was nation ID. Now this is interesting, and since it's a foreign key and it matches the ID field of the nation, which is the primary key, so its data type should be the same. So what do? I'll keep that as an integer. And we are done. Alright, so let's close that, and we have 2 tables now. Nations and shares. Alright, this is the foreign key, and right here this is the primary key. These 2 need to be linked. Fine, we created these 2 tables, which was straightforward, I would say, or assume. And see, interestingly, we have the data type as well associated with each attribute. ID is an int, code is varchar, right? So, yeah, so a lot expressive. Now we have these connectors, and these connectors are for our relationship. That's how we will define the multiplicity. I hope you remember the multiplicity concept, which defines a relationship, which kind of constrains a relationship, which determines like how many instances of one entity would be associated with how many instances of the second entity in the relationship. Okay, good. So let's and we know about the relationship between nations and shares. So one nation will have multiple shares, so it is one to many kind of relationship, and this is the connection that we would like to have between nations and shares. So how do we do that? Click this guy and then click shares followed by nations. So that's the trick. Okay, you click this relationship which is one to many, and after that the trick is that you first click the many side which is shares followed by nation side, right? If you change that, then yeah, you may not get the correct diagram. So if you want me to do that as a demo, I will undo it and let me start here. And I'm doing the wrong way, right? Nations and then shares, which is incorrect, right? So which is incorrect. So why is it incorrect? Because many should be towards the shares and this one should be towards the nations, right? So this is not correct. What we should do, we should do it other way around. So I will undo it, right? I'm doing it correct way, right? Previous one was incorrect. The very first one was correct. So choose this sign for the multiplicity, which is one to many. Click the many side first, followed by the one side. Right now we got the correct symbol. All right. So see, you can also when I am putting my when I am clicking this guy, so here it's showing corresponding. It is highlighting the foreign key, which is nation ID, right, with the ID field, which is the primary key. So foreign key to primary key kind of a relation you can see right here when you put your mouse on the relationship link. So that's it. It was so simple, right? And look at this diagram. I find this diagram a lot better than the corresponding one that we create using MS Access. All right. Yeah, so that was about the demo. I'll take you back to my lecture slides and I'll go over these things that I did one by one. So you need to install my MySQL Workbench first, and once that is successfully done, then you will go to Workbench. You'll find it out. You will double click, then it will ask you for the password. If you remember your password correctly, then it will take you to the first screen, and right there you will go to file, and from file you will create a new model. And when you say new model, then this is the screen that you see. You need to create click the add diagram, right? Add a diagram, that's what you have to select. First select a file, and then in the file new model, followed by add a diagram right here. Then from the vertical bar that you have here, you can select the icon, this icon which corresponds to the table. When you click this one and then you click on the canvas, then you see a table with nothing in there. Then you need to click that and you can edit that information in the section down below. That's what I did in my demo. Okay, we can make the first cut. That's right. You can add the columns in the table, and you can select the type of the attribute. Is it a primary key? Is it not null? So on and so forth. All right. And then these are some options that you get if you want to know about what these things stands for. Then PK is for primary key and N is for not null. If you remember, I made code as not null because I don't want the any entry in my table with the code value missing. I don't want that to be null. So that's the reason I'm enforcing not null in my example that I had in the demo. Similarly, UQ is for unique, bin is for binary, UN for unsigned, zero fill, and all that, right? Auto increment is something which you may specify. So by auto increment, that means that if you already had some 10 records and you are entering the 11th one, then automatically there will be another value which will be created for that field by incrementing the previous highest value. Good. So then you can use these symbols as I showed you to show the connections between these two tables, and I gave you the hint like how to click the different tables once you have picked the kind of relationships from this section right here. Alright, so now you have this task which is are we on track. So here you need to use MySQL Workbench and create a model for shares and nations database, something which I showed you in the demo. So that's are we on track exercise for you. If you are successful, you should see something like this. And the next slide would be on the homework number 2, which I don't want to give you right now. I might give you the homework by the end of this week. I will stop right here and I'll leave it on you. Please install MySQL Workbench as soon as possible and start working on that, because it will be required for your first part of the project. Alright, thank you. Have a good one. Bye bye.